So general review.
Sir, for the quiz on Thursday, will we also have all day?
I think so, yeah.
Okay.
You'll start doing class and then. Okay. So let's do first a few questions on integration. So let's do the integral. Let's start with this from 1 to 5 x plus 2 over the square root of 2x minus 1 dx. So how do we proceed here? We do a substitution. Okay, so remember, right, the notation is important here. So u is equal to 2x minus 1, and so du is 2 times dx. Okay, which means that dx is du over 2. So the integral becomes the integral, so okay, so I need to replace x, I need to isolate x here to express everything in terms of u. Okay, so this means that if I isolate x, I will get u plus 1 over 2. So I have x, which is u plus 1 over 2 plus 2 over the square root of u, and times dx, which is du over 2 from 1 to 5. Okay?
You have to change the bounds.
Thank you very much. Okay, so this is no good. We have to change the bounds. Okay, so let's change the bounds right away. So I'm going to do here bounds, space bounds. So if x is 1, then u is 2 times the 1 minus 1, which is 1. And then if x is 5, then u will be 2 times 5 minus 1, which is 9. Okay, so this is from 1 to 9. That's what you got to guess. And how do I get, so if I multiply top and the bottom by 2 to get rid of this fraction. So it will be x plus 1 plus 4, so u plus 1 plus 4, so it's u plus 5. And on the bottom I will have, so I multiply by 2, 1 to 9, so this will be now 4. 1 over 4, so. This is what you got?
Yes.
Okay. And then this is 1/4 times, so I'm going to separate into 2 integrals from 1 to 9. So u over square root of u is just square root of u, and plus 5 times u to the negative 1/2 du. That's what I have. Okay, so now this, at this point, you just do the power rule. So I'm going to spare time. I think you know how to do this now, unless you want me to do it still. Okay, this will be u power 3 over 2 over 3 over 2, and this would be u power 1/2 over 1/2 from 1 to 9. You should get as the answer 28 over 3. Okay, just I don't want to waste time on easy calculations unless you want me to. I'll do it. Okay, second question. Okay, because I just want to get as many done as I can in 1 hour. Let's try the integral from so just dx over x2 square root x2 minus 36. Okay, so this is now an indefinite integral. There's no bounds. Okay, definite, indefinite. Okay, go for it. So this substitution will be, it's in secant, right? So I'm going to do x is equal to 6 secant theta, and so dx is 6 secant theta tangent theta d theta. I'm guessing that's what you did. And let's replace dx of 6 secant theta tangent theta d theta over x2, which is 36 secant squared theta times the square root of x2, which is 36 secant squared theta minus 36. Okay. So are you guys okay if I cross out right away 36 secant squared minus 36? That's equal to 6 tangent. You see it? Or should I do the steps here?
Can you explain it?
Okay, so let's do it. 6 secant tangent d theta, and on the bottom, so 36 secant squared theta, and now here I will pull out 36, but 36, if I pull it out of the root, it becomes 6 square root of secant squared theta minus 1. Okay, and secant squared theta minus 1, that's tangent squared. And square root of tangent squared is tangent, so this will cross out with tangent. Okay, so I'll write it on the side because secant squared theta minus 1 is equal to tangent squared theta. Okay, let's cross out a 6, and we can cross out also a secant. So I can pull out 1 over 36 times the integral of, so secant over secant squared is just 1 over secant, 1 over secant is cosine. Is that what you got? Okay, so the integral becomes very simple. And so it's 1 over 36. Now I can integrate easily sine theta plus c. Okay, any questions? Okay, let's rewrite everything in terms of x now. So I have, let's go back to my substitution, which tells me that secant theta is equal to x over 6. But secant is 1 over cos. So 1 over cos is x over 6, which means that cos theta is 6 over x. Okay, so I'm going to draw my triangle here. The angle is theta, and this is 90 degrees. Adjacent of hypotenuse, so 6 over x. Adjacent of hypotenuse is the cosine. And so this will be x2 minus 36 square root. And we're looking for sine. So sine will be opposite over hypotenuse. Okay, so the answer will be 1 over 36 times sine, which is root x2 minus 36 over x plus c, and that's what I found. Okay, third one. So let's do integral x plus 4 over x times x2 plus 2 dx. So let's do this by partial fractions. X plus 4 x times x2 plus 2 equals, so a over x plus b over x2 plus 2. Is that okay?
I think it's bx plus c.
Very good. Okay, bx plus c. Okay, because it's the second degree. So this is equal to a times x2 plus 2 plus bx plus c times x over x times x2 plus 2. And so now we need to find the values of a, b, and c. So let's say if x is equal to 0, then 4 has to equal to, if I plug in 0 here, I get 2a. Okay, and so a is equal to 2. Okay, then I need to be able to cancel something else, and it seems that I can't. So I'm going to plug in x equals, let's say 1. So here I have 5. And if I plug in 1 here, I get 1 plus 2 is 3. 3 times a, which is 2, is 6. Plus b plus c. And so b plus c is equal to -1. Okay, now let's plug in x equals -1. Any I chose randomly, -1, just an easy value. -1 plus 4 is 3, is equal to, if I plug in -1 here again, I get 6. Plus, and if you plug in -1 in the x, so you will get a b minus c. And so b minus c is equal to -3. Am I correct? Is that what you got? Okay. So if I solve this, okay, so let's say I add both equations, the c's cancel, so 2b is equal to -4, b equals -2, and if b is -2, and c is 1. And so this integral becomes, so a, which is 2 over x plus -2x plus 1, right? -2x plus c, which is 1, over x2 plus 2. And all this dx. All right, equals integral 2 over x dx minus the integral 2x over x2 plus 2 dx plus integral 1 over x2 plus 2 dx. Okay, so this is very easy. This is very easy. Just this one, it's an arctangent, right? You have to do a substitution. Let me do it here.
Sir, I have a question.
Yes.
Since we've been doing a lot of this, if you know like the answer to 1 over x plus 2, could you just write it down?
This integral here?
Yeah, like if you just know.
Yeah, that in the exam.
Yeah, in the exam.
As long as you're sure of what you're doing, yeah.
Okay.
Okay with that. Okay, we've done enough. Yeah, we've done enough of these. You don't need to go through the x equals square root of 2 tangent theta and so on. Okay, it's fine. Okay, so now we have 2 ln absolute value of x minus ln of x2 plus 2 plus, what is the integral of 1 over x2 plus 2? You know it? No? You mean, you said you know it, you know it?
I didn't say no, so I just asked the question.
Okay. So let's do it. So I guess you guys don't know it. So let's evaluate this integral separately. Dx over x2 plus 2. So the substitution is x is equal to square root of 2 tangent theta. Dx is square root of 2 secant squared theta d theta. Okay, so I'm doing all the steps. Okay, so it's equal to 2 ln absolute value of x minus ln x2 plus 2. Notice that I don't put an absolute value here because x2 plus 2 is definitely positive. Plus the integral of, so on top I have dx, which is root 2 secant squared theta d theta, and on the bottom I will have x2 plus 2, which will be 2 tan squared theta plus 2. Okay, so 2 ln absolute value of x minus ln x2 plus 2 plus, so I'm going to pull out a 2 and pull out, so it's going to be 1 over root 2 times the integral of secant squared over secant squared, which is going to be 1 d theta. Two ln of absolute value of x minus ln x2 plus 2 plus, so 1 over root 2 times theta, and theta is arctan of x over root 2 plus c, and that's my answer. Number 4. Let's do the integral e power square root of, let's just do simple for now, dx. Okay, so I think this one we've done something very similar, if not the same before. First thing we do here is, like I told you, when you have a square root inside a function, it's always practical to set it as a substitution as a t. Okay, so t is equal to square root of x, and that would mean that dt is 1 over 2 root x dx. If I isolate dx here, would be 2 root x, which is 2t dt. Okay, so 2 root x dt, but root x is t, so 2t dt. And let's rewrite the integral now. So it's the integral of e, so e to the root x, so e to the t, times dx, which is 2t dt. So 2t dt. And now I can do integration by parts here. So let's do it. U is equal to 2t, so du will be 2 dt, and dv is equal to e to the t dt, which means that v is just e to the t. So I have uv, so 2t e to the t minus the integral of v du, which is 2 e to the t dt. Okay, and this integral is just identical, stays itself. So we have 2t, which is 2 root x, e to the t, which is e to the root x, minus 2 e to the t, so minus 2 e to the root x, plus c, and that's my answer.